Hello again, my fellow Jeti users. Welcome back to my workshop for yet another of my little training videos. And this one is about using Jeti with the Digitech Central Retract Unit, or CRU. Now, I had no intention of doing a training video for this because it comes with an instruction manual, or rather you download it from Digitech's website. And there are videos on Digitech's website about how to do the various bits. But to go through it fairly quickly, and I think for a lot of people might appreciate a bit longer explanation and demonstration of some of the more sophisticated features and how to program them. You can use the unit just sort of out of the box, get it up and running, and your wheels go up and down and your brakes work. But it can do quite a lot more than that for you, particularly in conjunction with what you're seeing on the screen here, which is the Lua app for the system. Now, if you've got one of the older transmitters that cannot run Lua apps or can't run big Lua apps and doesn't have a color screen, in other words, the 14 or a 16 generation Mark I, don't worry. You can do everything but run the Lua app, and the Lua app only deals with the presentation on the screen and some of the voice prompts. It doesn't deal with the actual programming or running of the unit itself. And so you still get full telemetry that you can set up alarms and log everything and see what's going on, even if you don't run the Lua app. So let's have a little look at what's going on, and I'll just start off by showing you a couple of the neat features that we'll get into later on in programming. What I've got here is a little foam board model with my retract set on it. So there's the nose, there's the right and left gear, there is central retract unit. We've got door servos, I've painted the arms red so you can see them, and a steering servo, and a battery for the receiver, which is there, and a battery for the unit. Although, because it has an output there, I could run both receiver and this unit off the one battery simply by plugging the receiver into the extension port there. I have also taken the opportunity to fit a switch,
inactivity alarm,
which is here. She always pipes up at the start of my videos because there is a button there, this orange button, to manually toggle the system up or down. But if you can't get to it, you can fit ideally a push button or a spring-loaded switch, because you don't want to leave it switched on, but I don't have one available, so I've just got a switch here just to demonstrate that you can do it. You can fit this in somewhere it's easy to get to in your plane if your central retract unit is buried away somewhere. Okay, so first of all, I'll demonstrate what would happen if everything's working nicely. So I'm going to select retracts down.
gear down and locked.
Okay, let's pop it back up.
Gear up and locked.
Now this time I'm going to select down, but I'm going to block one of the legs from coming down. And just to demonstrate a double thing, it's going to be the nose leg. So off we go.
Gear in unknown state.
Okay, so now we know that we haven't got everything down and locked. And that's because, as I say, I blocked the nose leg. And now the system knows that we haven't got down and locked. Also, because it was the nose leg I blocked and the system knows it, the steering servo doesn't work when I move the rudder stick. If I'd blocked one of the main legs, the steering servo would work. Okay, next what I'm going to do, I'll just cycle it, get everything down.
Gear in unknown state.
Right, although it's all down and locked, it's in an unknown state because the nose leg started from a wrong position, so it's not quite sure. Now what I'm going to do is select up, and once the wheels are up, the door servos will start to close the doors, and at that point I am going to block one of the door servos with my fingers. So here we go.
Gear door over current. Gear up and locked.
There. It told us gear door over current. Not only did it warn us about that as I blocked the door from shutting, it went into the door failsafe and it has opened all of the doors. So instead of trying to keep closing this door and burning up the servo, it just opened all the doors for me. So all the doors are open. Okie doke. Now, there's a couple of questions to answer. Why get a Retract controller and why the Digitech one? Well, smaller, cheaper Retracts, let's say the E-Flight ones, I know they're not cheap, but they're good, but they're cheaper than things like this. They have a controller built into them. So they come with a 3-wire servo lead and you plug it into your receiver and off you go. These bigger ones aren't like that. They have 2 wires, basically feed the current one way or the other way, and they work. So they need a controller to run them. And I could have plugged all the servos into the receiver and used a very simple controller for the gear, because I've got no problem at all programming all the sequencing in the Jeti. It's very good for that. But that would take me, say, at least one controller for the legs, another controller for the brakes. I'd need 3 sockets for the door servos, a socket for the steering servo. So we're looking at, what, 6 sockets required on the receiver, at least, in order to run this. Whereas, because this picks up from XBus all the data, I'm using 1 socket. Indeed, because I'm using a surplus expander socket, I'm not even having to use one of these servo sockets, although if you want to fit more telemetry and you need an XBus expander socket, then obviously you'd be having to use some of your servo sockets. But I'm using 1 socket instead of 6, which is good. And secondly, from that point of view, I effectively using the CRU as a socket expander. You see, that's a 12 channel, a 12
Inactivity
receiver.
alarm.
But Jeti receivers will pick up all 24 channels or however many you're sending. The number on the receiver is just the number of servo sockets it has. It's not the number of channels, just the number of sockets. And since I'm sending the XBus data and I'm running in 16 channel mode, I've got 16 channels to play with. So instead of using up the precious numbered sockets on the receiver for all these retract functions, I've put my gear, my steering servo and the brakes on channels 13, 14 and 15. And the CRU picks them off there. And that leaves me still all the original 12 sockets for other controls on the receiver. So we're down to 1 wire, 1 socket, instead of lots of wires and lots of sockets. And it effectively kept all my channels on the receiver, or sockets on the receiver, for operating the plane, and pulled out the 3 additional channels without taking up the receiver channels. Next question, why Digitech? Well, there are other controllers available. Electron makes quite a variety of controllers of different capabilities and prices, and I think JP Europe makes controllers as well. There may be others. The reason I went for Digitech was solely because it has this superb integration with the Jeti radio, meaning that I can do all my programming from the Jeti radio using the programming dial and the screens and the way of doing things that I'm used to. I don't need to get a separate little terminal with a screen on it to plug in with some weird buttons I'm not used to try and program it. It's all run through Jeti. And of course, we get Jeti telemetry. which means it's logging the currents, the various states of things, and of course the Lua app as well. So if we have any problems, we can look back through data logging on the graphs and see what's going on. So that's why I've chosen the Digitech one. I cannot compare it to the others. I'm not even going to try. I'm not specifically recommending the Digitech one. The others may be more suitable for you. I'm simply explaining why I went for the Digitech one this time, because it really integrates well with Jeti. So let's have a look at what's going on. I've done a factory reset now on the CRU, so it's back in the state that it would be when you get it. And in the radio, I have created my functions of gear, steering, and brakes. And just to prove it, I have assigned them out here to channels 13, 14, and 15. So they could not come out of the socket 1 to 12 on the receiver unless I remapped the receiver, but I haven't done that. So it's just to prove that we are managing now to get 15 channels in effect out of a 12-channel receiver. Now let's think about some housekeeping for your CRU. On the side of it down there, down here, is a USB socket. I struggled to find a cable. Eventually I found one because it's the type that was used by Android mobile phones quite a few years ago. But I found a cable. Initially that didn't work. First rule of computer problems, it's the cable. So try a different cable, and that worked. And the point of that is to update the firmware in here. Now I've just bought this CRU, brand new from the shop. It arrived a couple of days ago. But nevertheless, I thought we'll run an update, because in all my videos about Jeti stuff, I've said always keep the stuff up to date. When you get something new from the shop, run it through the Jeti Studio Updater. And so for this, you go to Digitech's website. They have the up-to-date firmware and a little programmer that will install the firmware for you, which you need to download as well. And it was well worth doing, because when I did that, it said that the firmware on this unit I've just got from the shop was firmware 0.95, and the latest one is 0.99, so it needed an update even though it was sort of brand new, as it were, and that went fine. Another thing you want to do is make sure you have the CRU device file in your transmitter, because without that, the Device Explorer just won't understand a CRU and you won't get the menus. And so again, that's on Digitech's website, although I found my transmitter already had the CRU .bin file, they're a .bin format, in the devices folder. So I'm not sure if maybe they're already coming from Jeti. But anyway, you can go and get the latest one of Digitech, and you download that onto your transmitter into the devices folder. The next thing, if you want it, is the Lua app, which you download again from Jeti's website. You put it into the apps folder on your transmitter, and then you can go into applications, choose it, and then in displayed telemetry you can select the sort of display you're seeing, and you can switch voice prompts on and off. So you don't have to have this gear up and locked or gear down and locked if you don't want them. If you already have a Digitech CRU and you're running the app, it would be well worth going to Digitech's website and downloading the latest app, because when I was playing around with it, I found a little bug in a couple of the voice announcements. In other words, the announcement that the gear is now traveling up or gear is now traveling down could not be switched off, even though you'd actually changed the setting to an X to switch it off. And so the chap who writes the app has very promptly corrected that and sent me the latest app, and he sent it to Digitech, so it should be coming up on their website. So if you find those prompts that it's going up or down and you don't want them and you can't find out how to switch them off, just get the latest app and it'll work. So having done all of that, let's get the system working. You would want to go into Device Explorer, first of all into your receiver, and you'll want to set the output for XBus, and it would help if I'd gone into the correct setting to start with. Alternative pin config, E1, expander 1, I've set it for XBus because that is what the CRU will work on. Certainly with Jeti. I have a feeling there's a sort of Futaba S-Bus version of the CRU as well, but obviously I bought the Jeti one. Okay, so we can plug the patch cable into E1 and we're ready for the CRU to work. And there it is in Device Explorer. As I said, I've done a factory reset, so it's all back at neutral, so we'll get to see how everything is programmed. Let's go through it bit by bit. General settings, device ID. This is the master, because if you've got a staggeringly complex model, you can actually build more of them in, and so you'd have slave ones. Orientation of the CRU is flat on bottom, or you can choose it to be on either of its sides. I suspect this only matters if you're going to use any of its inbuilt gyro functions. If you're not, then I suspect it doesn't matter at all about the orientation of it. Incidentally, here's something that I found in another of Digitech's products, the 2+2 expander. Whereas in Jeti, once you change something and you exit that field, that's it saved. In Digitech's products, they like you to press the Save All Settings button. And it will warn you if you need to do it as well. Okay, let's go into the Retract settings. Retract can be main and front gear or main gears only. See, I changed something, it's warning you, you've got unsaved parameters. So we'll go back to main and front gear. Incidentally, if you're using a retracting tail wheel, tail dragger, choose main and front gear. It's just that the tail wheel becomes the front gear in effect. Right, having done that, we'll pick our gear channel off the XBus. You go in there and lo and behold, just like any Jeti item where you can choose channels, there we go. It lists them all, gives you the names. There we go. Right.
Gear in unknown state.
Thank you. And it's now ready to pick up channel 13 as being the gear controller. So set gear up position. Put your gear switch, which for me is the one over here, into its up position and press that. That teaches the CRU what sort of timing setting the up is. Put your gear into the switch into the down position, come to here and teach it that one by pressing the programming button. There we go.
Gear down and locked.
Okay, so now it knows which way around the switch is. If your retracts are going the wrong way, don't bother reversing the servo as you might normally do in here, because all it will do then is teach it the opposite signals for gear up and gear down. And when you switch it down, the CRU will think you've switched them up. And although the legs may come down, all of its settings, timings, the Lua app will think you've gone up, and it'll give you all the wrong messages and warnings and stuff. So what do? Well, remember the wires into these controllers are just a 2-wire, and they may be color coded as they are on these, red and black, but they're not positive and negative, because you send the current one way to send the legs up, and you send the current the other way to send the legs down. So one time the wire is going to be positive and one time it's going to be negative. And on the CRU controller, at the gear sockets, it tells you which pins are positive and which pins are negative. But again, they will actually flip depending on whether you've selected up or down. So that it's not like something that has to be positive only on this wire and negative only on this wire. It'll just flip either way, like a light bulb. or an old-fashioned light bulb anyway, not an LED one. So if your legs are going the wrong way, just lift your socket out of the CRU, turn it round and plug it back in. So even if the red wire is going to what the CRU says is negative and the black wire is going to what the CRU says is positive, doesn't matter. It'll sort out the reversing for you. Okay? And down here we have the gear down and gear up delays. So if you want them to pause between you moving the switch, then you would set them here. Now, strangely, sometimes you get a gear down and gear up heading along here. Sometimes you don't. Let's say save all settings, come out of it, go back into it. No, it's still not going to tell us. Okay, let's select a 1 second delay on going down so that there's time for the doors to open. Okay, and so if I select up, they should move immediately because we've got 0 seconds, and I'm pretty sure this is down column, but there will be a 1 second delay on going down. So let's select up.
Gear up and locked.
And now I'll select down, hopefully get a 1 second delay. There we go.
Gear down and locked.
That's that. So let's save those settings. Scroll down one, that takes us back to the top of the menu. We can press back. Now, retract parameters. Normally, I think you'd pretty much leave the retract speed at 100%, because if you turn it down, then it's just going to try and run the motor more slowly by putting less voltage into it. I can't see the point of that. Electric gears tend to move nicely anyway, rather than slamming like air systems. The max current. This is the current at which the system will say, aha, the leg has reached its end point or a jamming point, and switch it off. So it starts off at 0.5 amps. We'll leave it here for the moment. The Digitech manual gives you some suggested currents for electrons and JP Europes, but we'll see how to measure it yourself. Max start time and max stop time, I'm not entirely sure what they are, but Digitech recommends leaving them alone, so we'll do that. Minimum cycle time, maximum cycle time. Now, this is particularly important for running with the Lua app, but the max cycle time is also important as well. This is the point at which it will say, well, if I'm putting the legs up or down and I've reached 8 seconds and they still haven't reached an end point, switch off anyway. So the legs will stop moving when either the current goes above the half amp or the time goes above 8 seconds. And I guess this is a sort of fail-safe mechanism in case something's running away or taking just far too long, something's gone wrong, or it hasn't measured the overcurrent, it will just cut out anyway. Minimum cycle time is defaults to 2 seconds. If the retract is blocked, jammed, whatever, in between 2 seconds and it coming to an end, then the system will think it's reached its end point. But if it gets blocked before 2 seconds, in other words, it hasn't reached its minimum cycle time, the system will recognize that we haven't reached fully up or fully down. And so if it stops at less than the minimum cycle time, that's what triggers that message I demonstrated at the start of the video by blocking the leg when it said retract state unknown. Now, really what you want to do then is set that minimum cycle time up pretty close to, but just under, the amount of time it takes the system to fully retract or fully extend. Because once you've started moving, once you go over 2 seconds, if you block it after the 2 seconds, it'll think the system is down and locked. Okay, so the next one here is the rewind time. Don't need to bother with that. Again, that's a good system setting. It's just that when the legs reach fully up or fully down, it reverses the motor just for that tiny fraction of a second to make sure that the nut is unlocked, ready for the next cycling. Let me show you, though, about the effect of minimum cycle time. I'm going to put the legs up. I'll wait for 2 seconds and I'll block it after 2 seconds.
Gear up and locked.
Which it clearly isn't. You see that leg? Because I waited for after 2 seconds to block it. So what you want is the minimum cycle time and the maximum cycle time to just nicely bracket the actual time that it takes. And then anything that takes less than the cycle time or exceeds the maximum cycle time, it'll stop everything and say state unknown. So let's select legs back down again.
Gear down and locked.
And what we'd like to do is set the max current and the min and max cycle times. Well, how are we going to find those? Well, the system has the data for you. So if we come down here into System Status, look down here. Here is the left gear, front gear, right gear, the current, in other words live current, and the peak that it reached. And these peaks are not trying to drive the system, as we'll see in a moment. Those are the peaks right at the very start or end when it's trying to get things moving, or it's hit the sort of jam at the end and the motor shorts for that fraction of a second. And it also tells you in seconds the last amount of time it took for the gear to move. If you're wondering why that one's so far out, that's because I blocked it on the way up. So when I selected down, of course, it only had a partial distance to move. So let's select gear up. These will go straight back to 0 and count. Watch the live milliamps there.
Gear up and locked.
Interesting. I have noticed that the right gear is struggling a little bit compared to the left gear, and if you were watching the live current there, it took more current and it's taken more time. But anyway, we could see that, 200-300 milliamps was all they were consuming normally. So if we've set the half amp limit, that's fine for the moment. Digitech recommends looking at these figures and adding 10% both to the current and the times. You might, if you've got some experience, certainly of air systems, think that you want to add a bit more than 10% just for the first flight, because often things like retracts, once they get high-speed airflow over them, and you could be doing 40, 50, 60, 70 miles an hour already by the time you retract your gear, the airflow and the angles of air traveling over things can slow things down a bit, hopefully less on electric retracts. But say you might want to build in more than a 10% safety margin just for the first flights. Remember, it's all logged in data logging. You can look it up afterwards and fine-tune things. So anyway, we'll work on a 6.3, 7.6. Add 10% to that. We're looking at certainly 8 seconds, which is what the system number was defaulting to, and the 500 milliamps was fine. But what are we going to set the minimum cycle time to? Well, 6 would be a bit tight. Shall we set it to 5 seconds as the minimum cycle time? That seems fine. So I'll come out of here, back to the Retract Parameters, and now I'll set the minimum cycle time as 5 seconds. Ooh, now this is useful. Digitech's menus sometimes do this, and I noticed this with the 2+2 extender as well. You can be changing something and the screen jumps and you can no longer see the box you're dealing with. So I'm just going to press the programming button again, press escape, and scroll there, and it gives it to us so we can get it back. So 4, 5, did it say 5 seconds? Yeah, and 5 for the main as well. Notice that we've got separate nose and mains if you need to. So now, as long as the legs reach their end point and the system stops between 5 and 8 seconds, then the CRU will be happy. It will report gear is up and locked or gear is down and locked, and whatever. If it goes over 8 seconds, it'll cut the power because something's going wrong. It shouldn't take that long. And if it stops moving at under 5 seconds, then we'll get that report of gear state unknown because it hasn't got to the end point. So let's prove it. I will this time set it off downwards, and in under 5 seconds I'll block one of the legs.
Gear in unknown state.
There we go. So whereas before it reported gear is down and locked, now it knows gear in an unknown state. Okay, so that's the effect of those and how to set them up. And don't forget, save all settings. Okay, front steering settings. This is your nose wheel. We'll ignore the gyro compensation for a moment. Come to the rudder channel. Down here, steer. Notice that I'm not picking up the rudder, although Digitech's written instructions say use the rudder. If you use the rudder, then obviously your steering servo is going to get the centering, travels, trims, rates, whatever that you're using on your rudder. And you might get away with that, but we've got the ability here. Why not use it? I prefer to create a separate steering function. It's not mixed to the rudder or anything like that. You don't need mixing. It's a complete separate independent function. And what I do is I go into digital trim and I change the trim button from being rudder to being steering, because on my jets you just don't need a rudder trimmer. You haven't got the spiral flow over the prop. And so as I'm taxiing out at the start of a flight, it's much easier if the thing's just off track to use the rudder trimming button to straighten up the steering, knowing that it's not affecting the rudder at all. So that's why I prefer a separate steering channel. If you want to take it off the rudder, that's fine. Set center position would deal with it coming up. Save all settings we have. If you want gyro compensation from the built-in gyro, you can do it here. Digitech's instructions say if you're using an onboard gyro for your plane that would do this to your rudder or steering function anyway, then use that. But if I had one operating the rudder, it's kind of easier to let Digitech operate on the separate steering function, because it will switch off the steering servo and the gyro compensation for the steering servo when you select wheels up. And as we've seen earlier on, jamming the nose leg coming down means not only does the rudder stick not operate the steering servo, but the gyro won't be working on your steering servo either. Whereas if you were using your other main gyro on the plane to operate it, then it wouldn't know anything about that and it would carry on trying to stabilize it. So all you need to do is say enabled, set the gain to whatever you want, gyro direction to be normal or reversed, and notice that a couple of new parameters have arrived now. Set left position and right position. So this would be the maximums that the gyro could go to. Okay, so I'll just disable that for the moment. I have to come back and make sure it is done. Yep, save all settings, because once again Digitech's menu just jumped there. Right, I'll ignore the door sequencer just for a moment, come to brake settings. Once again, pick up the brake channel. There it is. Set the no brake position. I use the slider on the left. You might use a button, a spring-loaded switch, whatever, but put it in the brakes off position and press the programming dial. See, it's red what the position is. Come down here, set your button, dial, switch, lever to the full brake position, press, and there, now it knows what that is. And gyro compensation we'll come back to, rudder compensation we'll come back to. So now if I move the brake lever, you can see the actual current feeding live to the brakes. And if you find that the model tends to pull to one side, what you could do is reduce the braking on that side. So say when we add brakes, it tends to pull to the right hand side. I'd want to reduce the right hand braking effect, and I can do it there. Okay. Pulse brakes. I'll just pop the wheels down for a second. There we go. Good. So rather than
Here in unknown state.
Thank you. Rather than the electromagnet just coming on at the proportional amount as you move your brake lever, it can pulse them. So if you select enabled, or rather just, you don't select enabled, you just goes from disabled into the percentages, and then operate the brakes, they'll feel a little bit notchy as it's pulsing. And you can turn it to a sort of faster and finer pulse rate. And this is actually jolly nice. I think silly me, knocked the camera there. I suspect I will use those by default. It's a bit like those of you of a certain age like me will remember cars before they had ABS braking, when the advice was if you're in slippery conditions, use cadence braking, which is using your foot to pulse the brake pedal as fast as you can, because if you just hold the brake pedal down, then the wheels can lock up on slippery surfaces. But if you pulse the braking, then just as it's about to lock up, you've taken your foot off, but you come back on again. And so this would help reduce the chance of locking a wheel and getting a flat. Right, the gyro compensation, if you enable that, you can set up a gyro gain. And what this does is, if you apply the brakes and the model's starting to veer, it will reduce the brake slightly on the inside so that it doesn't pull to the side. You know, you may already have your steering compensation gyro in, but this will help things because it will actually slightly reduce the brake, and the greater the gain, the more it will reduce the brake on the inside that's pulling. And it does work. I've been trying it with the pulse brakes and you can really feel the effect. And rudder compensation is a sort of brake steering. It's really meant for tail dragger models according to the instructions. But if you have it switched on, enable it, and then come down to rudder gain, then it doesn't give you brake steering in the sense that if you move left, it'll brake the left wheel. But if you put the brakes on some amount and then move the rudder stick, then on the outside of the turn, it will reduce the braking on that wheel. So you will get a bit of brake steering as long as you have a bit of brake on as well as move the rudder. Okay, so we'll disable that. Save all our settings. I've obviously got a bit of brake on there. Take that off. Okay. So that's our brakes set. And finally, the door sequencer. Now, the sequencer failsafe. This is the thing I showed you at the start of the video where I blocked one of the door servos from rotating its full direction. In order for that to work properly, you switch on the open doors. And the max current that's allowed. I turned it down to about 0.5 amp. If I turned it down too far, then just as the servos start moving, it goes over current and says, oh, it's failure. But I found that 0.5 amp was fine for this. It will be different in real life when they're actually trying to move a door with airflow going over it. So let's just sit with 1 amp as the default current for the moment. So if the door servos pull more than 1 amp, the system says, aha, fault, problem with the doors. It'll open the doors, all of them, for you. Come down to the door servo settings, go into door servo 1, enable it. You've got 4 servos here, and it now shows the live current through socket 1. The gear up position and the gear down position. If you're using what is often called P51 Mustang style doors, i.e. the door has to open to allow the retracts to travel and it then closes again, you might think, well, the gear up and gear down positions are the same. So really this is sort of door open and door close position. So this would be the door closed and door open position. It's just a simple timing in microseconds. In other words, it's like travel. In Jeti language, that would be plus 100%, and that's minus 100% travel. So you just go into it, and you can set the actual position of the rotation of the servo. And because this is Jeti, you think it's taking a long time to get there. There's an awful lot of scrolling going on. Press the menu button, and you can move it by tens or hundreds, like that. Okay, and thus you can rotate the servo quite happily around its positions. Set that back up to 2000 for the moment. And your gear down position. And because you've got this independent for up to 4 doors, you can get your doors nicely open and closed at the correct point. Time for the movement is the time the servo will take to rotate from one position to the other, 2 seconds, 1 second, or if you set for 0, you'll get the full speed of the servo. Now we've got 3 delay points. Delay when gear up, when gear down, and when reverse. So when you've selected gear up, how long should the doors wait before they close? So obviously you want to leave time for the retracts to get far enough up and then close the door. What delay do you want when you select gear down, if indeed you want any? And delay when reverse is the bit that deals with your doors that will open and then close after the gear has stopped traveling. So if you want the doors to open, then stay open for 5 seconds and then close. Set the delay when reverse to 5 seconds, and that will do all its job. And so you go through that for each of your 4 servos for the doors. I'll just make sure I've saved the settings. I probably had because it wasn't warning me I hadn't, but that's it. So now we've seen pretty much everything it can do. There's more statistics in here. Again, live current on the brakes. If I move the brakes, there we go. Door peak current. Uptime, bits and pieces there. Back, and some statistics. I'm not quite sure whether these are statistics for this session or all time. Anyway, what else do we need to do? Well, I mentioned the Lua app. Having copied it to the app folder on your transmitter, you come into Applications, down to User Apps, press the plus button and select the CRU display. What that then gives you is CRU display. And here we can set the maximum motor current and maximum brake current scales on the display. This is not for actual operation of the gear. This is what shows up on the display, and I'll show the effect of this in a moment. The audio announcement for gear is down and locked, gear is up and locked. You can switch that on or off. They're switched on. You can also have an audio announcement for gear retracting and gear extending. They're switched off. I think the only one I would use would be the gear is down and locked. So I'll switch that one off. Just don't want too many announcements going on. Anyway, look here, we've got 500 milliamps for the current, 200 milliamps for the brake. Let's show what the effect of that is. And to get those displays, you would go to Timer Sensors, Displayed Telemetry, and you can add either a CRU full screen or the 2-box. I've added both so we can see what they are. There's the full screen one, and if we move along here, there's the 2-box one, because that's a single box to Jeti. So you don't have to use up a full screen with it. You can show this. It's basically everything that's on the full screen, but in a smaller state. Let's have a look at this one then. And that 500 milliamps and 200 milliamps we've just set in the Lua app determines what in effect is the end point of the box here. So the graph will move along and it will count this end as 500 milliamps, that end is 0. And for the brakes, I think I'd set 200, was it? So if that end is 0, that end is 200 milliamps. So let's turn the brakes on, full on, and see what happens. The brakes aren't working because we haven't got a full system down. Notice we didn't get the gear up and locked message this time.
Gear down and locked.
There we go. And now the brakes will happily work. You see not much current going through to them at all. The bars here move to show the current that's going. There's a solid blue line there. That is a sort of tide mark. That's the maximum current that was reached during this last cycle. There's a grey bar, and that's the average that was taken on this cycle. So let's run it again and watch. Yeah. And the tide marks disappeared on this one because it's actually pushed it right up to the 500. Okay. And there's one other thing that's worth doing. The reason I was getting such small currents on the brakes is I've still got it switched to a very low pulsing rate. So if we go back into that, brake settings, pulse brakes 10%, I'll say disable that. This is where it's a bit annoying that it jumps. Save all settings. Good, come out of there. Now if I operate the brakes, yeah, you see much more current. So I would need to set the Lua app differently. Max brake current 200. Well, we were getting over 500 there, weren't we? So if we press that, we can go up to, say, 700. Let's see how that does. Now I'll operate the brakes. There we go. So now the end of the scale is 700. You can see that more easily. Okay, now you might get things set up and think, oh, I'd like to have a play around with it, but I don't want to lose my setup. So go into your CRU and press the Tools button. Export the settings. I've already exported one as CRU 1, so let's call this CRU 2. Okay, yep. And that's saved all the CRU's settings onto the memory card in the transmitter. And you can do this as many times as you like. I don't think you're going to fill up the memory card with these, you never know. And what that means is at any point in the future, you can come back to it and say import settings. And there will be a list of all the times you've saved settings. You could give it a more sensible name than just CRU1, CRU2. Give it the name of a plane or the type of thing you were trying to set up. And so you can go in there, select a whole setup file, and reload that. It will just put it back onto the CRU, and so you'll have a totally different way of doing things. I keep thinking I've made the last bit of the video and blah blah blah, so I'm going to have to do some editing here because I've now had to make about 2 extra additional bits. I forgot to tell you all about the data logging. Let's go into here, timer, sensors logging setup, and here we can see all the data that the CRU is sending, and you can choose to log it. Of course, so you've got the battery voltage, the live current for the gears, live current for the brakes, the current for the doors, I think it does a doors total, the gear state, the door state, there you are. And what that means is that having logged it, you can go into Data Analyzer and actually have a look at it. You can select your variables. Here we'll have a look at the current for the doors. There we go. It's not the doors, is it? It's the gear. Silly me. So the green line is the actual current taken by gear left. You'll be noticing some little very fine red and blue lines. That's the other 3 parameters. If you've got a 14 or 16 generation one with a black and white screen, it only shows 1 parameter at a time. And so these ones are just overlaid in it very finely. You can see by comparison what's going on. So now you can read the maximum current that was taken. Let's move on to the next one. Gear right is the dark blue line, and gear front. Interesting spike there. So all these parameters are there. As I said, you might want to use more than a 10% margin on the current and the times for your first flights, in case you're worried about things stopping partway due to the effect of airflow blocking things. But after the flights, you can come back, you can have a look at what really happened in your plane when you switched things, and therefore you can tune the maximum and minimum settings to suit. And if you're having a problem with any gear, you can come in here and see what the current was actually spiking at, and therefore what was going on. So have fun with all of that, and we'll see you sometime for another video.